Lesson 63, Intro to Vectors. A vector is a quantity that has both direction and magnitude. Oh yeah. Okay, so magnitude is like length. Okay, so it's not exactly length, but it's very similar to length. Just has kind of a different label. A scalar is a quantity with only magnitude. So a scalar it's like a number. It doesn't have any direction. So it's like if you found the length of a segment. So it didn't matter which direction. So a scalar just has magnitude. So in a vector, we have the initial point, the name, and when we write the name, we draw an arrow with only half of the end arrow part. And then we have what's called the terminal point. Because it has an arrow does not mean that it continues on forever. The arrow just indicates what direction it is going in.
What's that line?
This is an arrow without the bottom part. So it's just the top part of the arrow. So when we write a vector name in these bars, that means magnitude. Which makes sense because absolute value means distance from 0, and this means magnitude, which will be positive, because you can't have a negative magnitude, I don't think. Okay, we generally place a vector on a coordinate plane with the initial point on the origin. We write the component form, so it's kind of like when you write the point where you have parentheses and you put the x number and the y number. The way we write vector in component form, the component form of a vector is, and we do these kind of pointy parentheses, I don't know what you call them, horizontal change, and then comma, and then we write the vertical change, which is exactly like how we write the points, only we don't use parentheses, we use these thingamabobs. So here's an example of a vector. We're going to call it vector t. The terminal point will be at 2, 3, and it's vector t. So to write the component form, we just write 2, 3 in those little pointy parentheses. So it's just like writing the point. Opposite vectors are moving in opposite directions. So, if you have vector 2, 4, the opposite of that would be -2, -4. So if you were to add those component forms, you would get 0, 0. So when we add vectors, to add vectors, we just take the sum of their components. So the vector 0, -4, plus the vector 0, -6 equals, and then we just add the 0 plus 0, and the -4 plus -6, -10. So these two vectors together would result in a vector of component form 0, -10. Okay, I'm going to give you an example word problem, but I have to turn the page. Do I have your permission?
Nope. That was so long.
We just have one.
I'm sorry. That's right in here.
I can borrow you my notes when I'm all done. Okay. Now, I don't draw very well, but we have a person in his inner tube. Remember, let's see, he's, whoops. The legs kind of come out this way. And somehow he's holding oars.
Why oars?
I don't know.
Okay.
Because she's rowing.
In a tube.
That's really hard. Okay, so anyway, you're going to draw this. These are your parts.
You have to draw.
Okay, and then, oh, this is terrible. And then she's in a river.
Oh, what is this?
It's a river.
It looks like she's standing on the bottom of the tube. Like falling.
Oh yeah, she's,
By your feet.
okay,
No, by your tongue.
so this is our word problem. The river is running, you don't have to draw the picture if you don't want to,
Okay.
5 miles per hour, and the girl is rowing at 2 miles per hour.
10 miles per hour. No, 7 miles per hour. 2.
And she is going downstream. So how fast? Mhm.
7. Yeah, I didn't get it. I remember. It's either 7 or 10.
It's 7.
Okay.
Yep, she's going 7 miles per hour. So if we were to write the vector for the river, it would be 5, 0, and then the vector for her rowing speed, and then we just add them together to get the 7 miles per hour. So if she were going upstream, how fast would she be going?
3 miles. 3 miles per hour.
Wait a minute, but the river's running 5. She's only paddling 2. So she's actually going down. No, she's
Getting pushed down.
getting pushed down by 3 miles per hour. So she's not rowing hard enough.
Rowing upstream. She has to be rowing 5 miles
And she's
per hour.
going
Sit there.
downstream.
She has
Yeah.
to go like
She's
at least
rowing
6 miles
upstream
an hour to
and
go
she's going
anywhere
down.
upstream.
Yeah, she does. If she, oh, what if she's going upstream rowing 5 miles per hour?
Then she won't go anywhere. She'll
She's
stay
standing
place.
still. Okay.
Unless she goes side to side.
Okay, that's the end of the lesson today.